This is the lecture for Calculus 1, section 4.3. And this section is just getting us more familiar with integrals. And this section talks about properties of integrals. Some of these properties are going to kind of just like make sense immediately, and then some of them won't make any sense. And that's because we don't quite have the full definition of a definite integral yet. I gave you an idea of what it represents in the last section, in section 4.2, but we don't have like the actual definition of the definite integral. That will come in a later section. I don't remember exactly what section, but that'll come later. And once we have the definition of the definite integral, like the actual definition, the formal definition, then hopefully these properties will make sense. Right now, some of them might be like, huh? So I just want to make you aware of that. So like, don't feel like it's like there's something wrong if the property doesn't make sense right now. I just want you to practice using it. And then next week, the clouds will part and the light will shine, and you'll say, oh, it all makes sense. That will happen next week. Okay. So I'm going to write the properties down now. Actually, it just occurred to me, before I write the properties, sorry, I just got some bad news about the world, and I'm kind of flustered right now. A friend just texted me. But I was going to say, so that's why my mood all of a sudden changed from happy to just really flustered and upset. But I will keep making this video. So before I write the properties, it occurred to me that I should just let you know the language for these numbers right here. So I talked about these numbers in the last section 4.2. A represents like where you start, B represents where you end. These numbers, they have names. They're called limits of integration. So I'll be using that language sometimes. So I just want you to know that that's what those are called. A is actually referred to as the lower limit, and B is referred to as the upper limit. So as I talk about the properties, I might be using language referring to the upper limit, the lower limit. So, okay, now I'll write the properties. So here are the properties of definite integral that we'll be working with today, and properties for you to keep in mind throughout your time working with the definite integrals. So the first property, I think that one will make sense to you, to everybody. Just that if your limits of integration are the same, so like you go from A to A, you're not really going anywhere. And so the area underneath the curve from A to A is just going to be zero. Like there's no area. You're not going anywhere. Right. So you might recall from section 4.2, I'll come back to this, but you might recall from section 4.2, how I talked about how the definite integral from A to B of f of x dx, it represented, like if this is y equals f of x, and here you have A, and here you have B, that definite integral is this area, right, from A to B. But if you're going from A to A, there's no area, right? And so that's why that's zero. So I think that one makes sense. But then the next one might not make sense. It probably doesn't make any sense. There's no reason for it to make sense to you right now, because we kind of need the definition, like the actual definition of the definite integral for the next one to make sense. But I just want you to notice what this is saying. It's saying that so normally when we talk about definite integrals, we'll like our lower limit, the smaller the number at the bottom of the integral symbol. Usually that number is going to be smaller than the number on top. Like, so we'll start at A and end at B, right? The idea with is that A is smaller than B, and we're going from left to right. But if you start at B and end at A, that actually ends up switching things around, and you end up getting the opposite of the definite integral from A to B of f of x dx. So that's the second rule. And again, doesn't really make sense. Like, it's like, why right now? Maybe you're asking, why is this true? And you'll find out next week. Let's see. The third rule, I think the third one can make sense. So basically this is saying that if you have, let's say you have a curve, right? So let's say you have this curve. This is y equals f of x. And let's say that here we have A, and over here we have C, and here we have B, right? So this is basically saying that if you take the definite integral from A to B of f of x dx, so you take this area right here, and then you add it to the definite integral from B to C of f of x dx. So you add it to this area right here, you're going to end up with a total area, the definite integral from A to C of f of x dx. So that's everything, right? That makes sense, intuitive sense. So that's the third rule. And then the fourth one, that's one that won't really make sense until we see the definition of the definite integral, the actual definition. And just one thing here, k is a constant. So basically, if you have the definite integral of a constant times a function, you can kind of like factor that constant out. There's a reason I use the word factor, because that's what we'll be doing next week with definite integrals once we have the definition. So, okay, so let's look at some of the homework to practice these rules. Number 2 is actually like 4.2 problem. So let's start off with number 3. So notice like here, they give us these limits they give us the definite integral from 4 to 11, right? And they tell us that this is equal to 51 over 11. And then they ask us to find the definite integral from 11 to 4. So the limits of integration have been switched. And when that happens, just stick a negative in front of the value, the original value. So this will be negative 51 over 11. That's the second rule that I wrote, the second property. Just write, this is property 2 that we're using right here. And that's that. It's like, so they want to know that when you switch these numbers. So usually the number on bottom is smaller, but if you have the bigger number on the bottom, you end up with the negative just because of the definition again, which again, we will talk about next week. Okay, let's look at another problem, another. Look at number 4. What a mess that looks like, but don't get stressed out by the mess. Notice what you're going to notice are these numbers. Notice your limits of integration. They're the same. Whenever they're the same, you're not going anywhere. So there's no area. So this is just 0. So I think they just made this like look as messy as possible. So you could be like, yay, I don't have to deal with that mess. Yep. Let's go back up to the first problem. I kind of skipped it. We won't do the second problem because this is like 4.2. But the first problem, it gives us definite integral from 3 to 9 of f of x dx minus the definite integral from 3 to 8 of f of x dx equals the definite integral from what to what. So they want us to give them the new limits of integration. If we take this area minus this area. So let's just draw a picture to imagine what's going on. In case you don't see it right away, it can be helpful to have a picture. So that's what we're going to do. So let's just imagine that we have a curve. I'm going to draw this curve. Let's imagine we have a curve, right? And this is my y equals f of x. Y equals f of x. And let's suppose that, right, here we have 3. Let's say this is 3. Okay, sorry, my scale is going to be off, okay? But we don't care. We can still imagine what's going on. And here we have 8, and then you see my scale is just like way off, right? But we can still imagine what's going on, okay? Okay, so the definite integral from 3 to 9, that that I will color in orange. So so here we have, we're going from 3 to 9. And so that's this, what I'm shading right now, this area. That's my definite integral from 3 to 9. Everything, this area shaded in orange, right? And then it says subtract from that, you're going to subtract the definite integral from 3 to 8. So what color should I make that one? Let's make that one green. So we're subtracting the definite integral from 3 to 8. So we're going from 3, same starting place, but to 8. And we're subtracting this part. So we're subtracting the part that's in green right now. Everything shaded in green. This we're getting rid of. Goodbye. 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 Everything in green. And all we're left with is 8 to 9, it looks like. So it looks like that is those numbers, the 8 that we're left with, and the 9, like we're just going from 8 to 9 now, since we got rid of the 3 to 8 part. Those are our new limits of integration. So for our answer, I get to say that the 8 is going to be my A, my lower limit, and the 9 is going to be my B. And so here I'll put 8. And then over here, 9. And I'm done. I think maybe we'll look at one more problem. And then that'll be it. Let's look at another problem. Oh yeah, there aren't that many problems here. So you can try doing number 5, but let's look at number 6 because it looks like there's a lot going on here. But actually it's not much. So it looks really messy, but it's actually not bad at all. It's asking us for the definite integral from -55 to -43 of 7 times f of x. Notice they give us the definite integral of just f of x. And then plus 4 times g of x, they give us the definite integral of g of x dx minus h of x, which they give us. So, so what we're going to do is use what we're given and use what property? The fourth property as well as the third. Well, I guess just the fourth property, really. Like this idea that you can like factor out a constant. So notice there's a constant in front of your f of x. So for this, you will have, so just focusing on this one right here, right? The definite integral from -43 to, sorry, from -55 to -43 of f of x dx is 15. I know I will start off with a 7. So notice there's a 7 in front of my f of x. So you just bring that 7 along, and this will be times the 15 that my f of x's definite integral is. And then it says plus 4 times g of x. So now I'm adding 4 times g of x. I go to my definite integral of g of x dx is 28. So this will be plus 4 times 28. And then last of all, it says minus h of x. And my definite integral of h of x dx is 31. So this will be minus 31. And really, that's all. That's all you're doing. As messy as that looks, you can understand it, hopefully. So let's put this in the calculator. So we'll have 7 times 15 plus 4 times 28 minus 31. And we get 186. Where are we? Where's the, here it is. 186. And there we are. So take care, everybody. Bye.